AI won't necessarily take your job. It's those that don't know how to leverage AI that will potentially have a challenge here, right? But I don't want to get too far into that. That's a whole nother discussion beyond the scope of today's course, right? Today's discussions. Yeah, is it necessary to learn AI and ML for everyone? No, learning it. So there's different degrees of learning this stuff, right? And I don't want to get too far into the Q&A just yet. We'll kind of have some conversations and we'll get back to some of this stuff. But what are we talking about learning? Well, there's one side of it as being a user of AI. And I would argue a lot of people need to learn how to do that and basically prompt AI, ask it what to do, what to produce, right? And there's like a whole skill in what we call prompts in prompt creation. There's a whole skill in that. And then there's the other side of it, the people actually creating the AI, right? And so in that regard, when we say no AI, not everybody needs to know how to create the AI. That's actually a very niche kind of skill. But more and more people are needing to actually learn how to use the AI as a user, know how to prompt it and leverage it. Because if you don't, it's not that you can't do your job. It's just that the person next to you is going to do it 10 times faster and 10 times better, right? Because they're using the tools at their disposal. Okay, that's how I see this stuff. Is AI is now it's become a tool for us. Most people remember when you go through school, right? Let's say when you're a child and you're just learning how to do math, right? You're just learning how to add and subtract, multiply and divide, and do all these different things. And then one day they introduce a calculator to you. And once you're allowed to use the calculator, your brain just kind of goes, oh my gosh, I wish I could have been using this the whole time. Well, it would be silly to go through life insisting that you never use that calculator. Go through life insisting that we're just going to do it by hand. There's nothing stopping you from doing that math by hand, but you'll fall way behind. If you're somebody in the math business, it would be silly for you to do that because your competition will just blow you out of the water, right? At that point, you really need to focus on using the tools at your disposal. And that's what AI has become now, is it's even writing programming code for people, but it doesn't mean it's writing entire applications, right? We still have to direct it to kind of write these code snippets and these chunks, but it speeds up development efforts like crazy. And that's just one example. If you're a content writer, if you're a journalist, you can be using these things to help kind of maybe improve your writing style or kind of get like a baseline in the place, and then you can go through and modify it for your own use, right? Okay. So just kind of show the results in this. Right. So it looks like about 71% of attendees, their organization currently has a strategic plan here. And then another 23% just don't know. So chances are I would be willing to guess that a large percentage of the people that don't know, it's probably a yes. This is just something more and more companies are realizing they kind of have to at least dabble in this because their competitors are. And so anyhow, all right, that's fantastic. All right, I'm going to go ahead and stop sharing the polls. And risk mitigation strategies in place for AI ML. Yeah, that's a great question. Yes, there's a ton of security around all of this. In fact, again, we're using AI and ML a lot of times for security. But as far as risk mitigation, risk protection, there's a lot of discussions around that. So the question is how much you just let it go wild. Right? Most AI platforms today are not built that way. They're not built to just kind of be open-ended. We leverage it just like any other tool. At the end of the day, we are probably still directing on exactly how we want to use it and leverage it within our environments. It's not just open-ended. So there's a whole lot around mitigation of risk for sure. With that said, though, you could also argue the flip side of it. There's also lots of risk in not using it. And so there's discussions on all of that. Okay, so let's kind of get into this. Let's talk about the big picture. First off, this was an old quote from a Space Odyssey. I don't think anybody remembers this, right? Any sufficiently advanced technology is indistinguishable from magic. And this is kind of the way it's starting to appear, right? People that don't work in this landscape are seeing AI and they're going, oh my gosh, what can't it do? And you're seeing it pop up everywhere. If you've got a smartphone, it's popping up on your smartphone. You're doing Google searches, it's popping up in your Google searches, and so on, right? All right. So let's talk about understanding traditional AI and ML. So when I say traditional, I want you to understand first off that AI is not new. In fact, a lot of these theories and concepts actually started all the way back in like the mid to late 1940s. John McCarthy, an individual back in 1955, actually coined the term artificial intelligence. And a lot of the theory that was developed then was way ahead of its time, meaning there was all this mathematical theory, but they didn't have the computer systems to actually, invoke that theory completely. And so some of the stuff we're doing today is actually still a derivative from that era, which is kind of crazy. But also, there's a lot today that doesn't look even close to what was envisioned back in 1955. And so, but just I want to point out, this is not new stuff. We're just evolving, and then what's going to happen with AI is it evolves itself. It evolves itself faster and faster, right? Because we can use AI to improve AI, and so it's an accelerating thing, and that's why in the last like a year or two, this has gotten so big so fast. So there's these different types of artificial intelligence. We have what we call classical based programming. Basically, it's you write fixed rules. So you have a programmer, and a programmer writes these rules that says, in this condition or this situation, do this, right? And it's very responsive or reactive to the thing it sees, and based on those rules that have been defined. So a simple example to this is the old test that used to be done years ago around playing chess. This was a thing. I don't remember the exact time frame on this, but a computer playing a human being in chess. And you take some of the top chess masters in the world, and it actually took a while for the computer to beat these experts, if you will. And it was all based on rules. And so basically that meant it knew, the system knew the rules of the game, and it kind of knew you'd hard program these situations. So basically, if the board looked like this, here's your next probably best move, right? And traditional. Thank you for that. Yeah, I missed that one. Thank you so much, Paul. I should have used AI to check that. I'm not a good speller. So in any event, so the AI world is started with just these hard-coded rules, okay? And so the rules are just hard programmed, and the problem is it wasn't very dynamic, right? And so it had to be programmed rule after rule after rule. Hey, you see this situation, do this move. You see this situation, do this move. And it was a very kind of static thing. And it wasn't until enough rules were developed that it could get good enough or smart enough to actually beat the players, okay? This actually becomes a problem in and of itself too, because the rules become kind of endless in that it gets bigger and more bloated. So now you have not just 10 rules, you have 100 rules, you have 1,000 rules, tens of thousands of rules, and it just weighs the system down. It gets very slow and inefficient. And so in that regard, the rules really kind of had some limitations, right? So then enters the machine learning landscape. The machine learning landscape is quite interesting in that machine learning actually allows it to derive the rules from the data. Okay, so this is where you're going to choose things in the data that you believe are important. So a human being will actually choose important elements. Most basic example, let's say we're trying to build some sort of system that will detect whether something is a car or an airplane or a motorcycle. Okay, those three things. And so those problems are usually done by us selecting features. And so in that case, I might say, well, a car has 4 wheels, it's got a windshield, it's got some headlights, it's got a pair of headlights, and so on, right? Then you've got an airplane, has some wings, right? It's got a tail, and then of course it may have 2 wheels, 3 wheels, depending, and then it's got a propeller potentially, right, or a jet engine. And then, of course, a motorcycle, 2 wheels, and obviously an engine, a headlight, and some other things along those lines, perhaps. Okay, maybe. So my point is, you kind of call those features out. We as human beings in machine learning would actually call those features out and say, here are the things that I believe are important to make it identify what's what. Okay, so when we do this concept of training the system, the training of the environment is kind of like I'm going to show you a flashcard of a car. I'm going to show you another one of a car, another picture of a car, another picture of a car. And basically, eventually, you start to kind of notice the differences and the similarities. And so the idea is with machine learning, we kind of call out these features. And then what can happen is something new can be introduced that it's never seen before. And it's got enough features that it can say, you know what, I believe that's a car. That's the general idea of machine learning. And so it's about this kind of algorithmic kind of approach, along with basically probabilities, is what all of this stuff comes down to, probabilities. But basically, this whole idea is human beings had to provide those features. The problem with providing features is that in and of itself, sometimes we don't know what to provide. We don't necessarily know what makes something unique. And so sometimes that's a challenge. And so there's another type of machine learning where you could do like grouping or clustering, as they called it. So basically this idea of let's say I showed you stacks, I showed you a bunch of pictures. And again, car, airplane, and a motorcycle, and those are the three possible options. And we got stacks of a couple hundred pictures, and I say to you, group them. And so you may not know the name of something, you may not know how to call that a car or an airplane or a motorcycle, but you might end up with three separate piles of things that look similar. And naturally, it might be a plane pile, a car, and a motorcycle pile. And that's without me giving you any input on that. So machine learning had that ability as well. But really, it was about kind of like categorizing things and identifying, where to place that thing in a category. That was most of machine learning. So then came on the scene this concept of deep learning. This is where things get really interesting, and this happened around 2012, where in 2012 the deep learning stuff really kind of took off. 2010 to 2012. Deep learning is not from that era. In fact, it actually was developed much longer before, but our hardware couldn't keep up. There was what we call a neural winter, where basically our hardware wasn't good enough to do what deep learning could do, and we required these like really high-end pieces of hardware. But around 2010 to 2012, the hardware became available, and we got a whole new spur in AI. Specifically deep learning. And what deep learning does and what makes it different from machine learning is that it allows the technology to actually derive its own features from the data and its own rules from the data. Okay. And so in that regard, if I just showed it a picture of a car, it would pull out the features and the edges and the corners and all these little things, and it may derive thousands of features about a car, making it far more accurate. And it would kind of identify those things that make a car a car. Okay, I don't know if anybody here has ever used like facial recognition. Let's say on their phone. Let's say you have your phone or your desktop, and you're using it to log in. Okay, if any of you use those types of features, well, on your phone or on your computer, when you go to log in with that, what it does is when you train it, when you teach it what your face is, it's identifying features of your face. But it's not like, hey, you have two eyes, it's and a nose and a mouth. It's actually looking at every little freckle, every little bump, everything. And there might actually be thousands of features that make your face yours. And this is what's interesting is back when we were really dealing with COVID at full scale and everybody was kind of isolated, I had a case where I was logging into my computer and I had a mask on. I had a hat on at the time. I was just doing work on my own, kind of behind the scenes. So I had a hat, I had a mask, and I had my glasses on. And it was still able to recognize that it was me. And really it's because of, specific wrinkles in my face and little spots, that enough of those were still identifiable that it could say with confidence that, yeah, that's that person. Okay. And so instead of a human being calling out saying, here are the features that you have to identify, the system identifies those features itself and actually learns to do that. Okay. Oh my gosh. Dinesh, that's crazy. Yeah, that's not great. Right. Twins. Yeah, that's a tricky one. All right. Because facial identification, until it gets down to like the retina or whatever, I'm sure there's probably still things you could do that's still unique. But I would guess, though, if somebody has a twin, maybe they should opt to not use facial recognition for authentication. It's up to them. But very interesting. That's kind of crazy. So, but yeah, that's the whole thing, is it identifies that. Now, I would also argue that's not necessarily anything saying about AI itself. That's about that implementation of AI. There are ways to basically adjust that threshold of to how precise it needs to be before it accepts who you are. And so every single implementation is different on that, whether you're using like a Microsoft laptop and logging in with your face, using an iPhone, logging in with your face, logging in with an Android phone, whatever it might be. They're all going to implement a little bit differently and have different thresholds and different standards, right? Now, obviously, if you're working at some top secret facility and they're doing facial recognition, they're probably going to have a higher level of requirement to pass by that, right? So yeah. So no, so it's more than that. Deep learning, I was using that as an example with things like facial recognition and image recognition. Those are just simple examples. But the point is, it recognizes, it learns what is important to identify things and to do work. And so it's actually deriving that itself. It's not relying on the human beings to say so, right? One of the challenges that we've always had with traditional machine learning too is biases that get introduced into the system, where the programmer, if you will, programs the machine learning, right? And the programmer or the data scientist or somebody is saying, here's what we believe to be important in making these decisions. The problem with that is now you have human biases in this whole thing that can lean it. You can kind of create a bent, and that's not good. Deep learning may still be somewhat subject to it based on the algorithms and things, but for the most part, it kind of reduces that biasing, because at that point, deep learning is actually deriving that feature itself, right? It's figuring that stuff out for itself. I'll give you some really good examples of kind of comparing these in a more traditional sense, talking chess, the chess example here in just a minute. Generative AI, however, is a form of deep learning. So all of these things are cascading. Classical-based programming or just general AI encompasses all of these things, I should say. So general AI, first stage would be classical-based programming. Then deep learning is kind of the deeper stage. And then deep learning, even more precise, more specific, and maybe requires more hardware and more resources. And then generative AI is actually a form of deep learning. So that's where all of these things kind of like are within each other. Okay, generative AI is a special type of deep learning that actually came about kind of based on a lot of principles that were discussed in this 2017 white paper. Attention is all you need. You can go look that up, and there's some really interesting information in that. There's blogs written about it and stuff too, if you don't want to actually read the white paper itself. But I basically kind of just laid this out just to kind of have a visual here, right? So we have artificial intelligence, and we have features that are derived from the data. Oops, actually, I meant, let's go there. Okay, I'm sorry. So overall artificial intelligence, that was actually a mistake. Artificial intelligence here. Inside of that, we've got classical programming, which I didn't actually have a chunk for. Then we have machine learning. And so in machine learning, humans supply the features. So this is what I was talking about, where we choose the features, the system derives the rules. So let's put this into context around chess, okay? So with chess, we've got the classical programming model where we write all these rules, okay? Well, what we do with machine learning in that concept is you get a record of a bunch of past played chess matches. So maybe you have every move in the form of data that has been recorded, and maybe you supply the system thousands of chess games. And so what it does is it learns the rules, and the rules being what moves to make, or how the pieces move on the board, and it kind of derives a lot of that stuff from that data. So you just supplied a bunch of games that's been played, and it can actually learn how to win the game based on those past games. Okay. The problem is we do have a limitation on how many past games have been played. There is some finite amount there, right? And then as far as the humans supplying the features, we're talking about what do we think is important in identifying what moves to make, right? And so that's the features. With deep learning, if I can get this to advance properly. With deep learning, we have this idea where it derives the features from the data and the rules as well. And so this is an interesting thing because what it can do here is deep learning can actually play its own games and see the results. So we really kind of focus more on the outcome we want and allow it to iterate on its own. So now instead of feeding it, let's say 10,000 past chess games, it could play its own chess games against itself to see and learn what those moves do and accomplish. And now it could train off of hundreds of millions of games if it wants, right? It could actually just play those things over and over and over again. And so it's basically simulating, right? It's able to make these simulations and see what the outcomes are and learn what the best moves are. That's what deep learning would essentially be. Okay. Now, then where generative AI actually comes into the mix is this is truly able to create new original content. Okay. So deep learning was always based, deep learning and machine learning were always kind of based on historical data. A lot of times deep learning, not necessarily historical data, but I'd still have to supply it some sort of inputs a lot more. And it wouldn't necessarily create new content. It would come up with ways to beat the game, right? So a lot of times, deep learning and machine learning were used for things like, what to do next, a single prediction, or categorizing things, right? Identifying fraud, all of those types of things. But generative AI takes us into a whole new level where we actually generate completely new content, okay? And so the way this generally works is it's got an element that generates the content and it puts it up against an engine that is analyzing past content to see if it kind of matches these rules that have been derived, right? So it kind of like looks at the original, or looks at various original works, which could be many petabytes of information, or exabytes even of data. So this is where there's massive amounts of data available to us, and it can kind of generate new work based on that data still. But what it's doing is it's learning from that data and generating new things completely. Those new things might resemble what it learned, right? It's going to, just like if you did, right? If you went to a class and you were taught something, your knowledge is going to be based on what you learned, what you were presented, right? So it's very common that you may have some level of seeming to repeat something, but you're not just regurgitating what was told to you necessarily. You might be reframing it in your own words. That's kind of the way generative AI tends to do what it does. And the more data it has, the more it can produce unique works. Some of you may not realize this, but a couple years back, AI was able to win an art contest where nobody knew it was AI-derived art. And it kind of ruffled some feathers. Right, but it was quite interesting that AI was able to actually be artistic, and that was a big thing because that's always something I always thought. Right, for years I always thought, well, we'll leave the artistic stuff, the creative stuff, up to the human beings, and we'll do the repetitive work for computers. Right. So this is kind of crazy, right? We're actually now at a point where we can create new content. Now, this new content could be text, it could be video, it could be images. There's all these like deep fake videos circulating the social media. I mean, there's obviously big problems along with some of this stuff too, right? So there's new challenges that are emerging, and I don't know if we have all the answers yet, right? And it might be a while before we totally do. But bottom line, the world as a whole is leveraging this now, right? So this is just kind of the big picture about kind of where it all fits. Generative AI is kind of looking at massive amounts of internet data, as an example, and private data. Data sets that have been supplied to it. So we've got all this information being supplied, and it's learning from all of that. Everything from medical, I mean, it can learn from medical documents, it can learn from legal documents, it can learn from blog posts, it can learn from current trends on things, images and styles. I mean, there's products out there now to make your own imagery for some personal image you're trying to create, marketing content, all sorts of things, right? Yes. So that's exactly it, Dinesh, that GenAI does use deep learning. That is absolutely true. That's why I kind of embedded it that way, right? In this kind of outline. All of this is artificial intelligence. Artificial intelligence can mean a lot of things, generically speaking. Then you have machine learning, which is part of that, and then deep learning. Deep learning is a form of advanced machine learning. Generative AI is a form of advanced deep learning. Okay, so they're all kind of stages as you get deeper into this discussion, right? So yes, at its core, Gen AI is deep learning. Okay. So again, in this case, it's a subset of AI technologies. Again, deep learning, as we talked about. And again, you can do everything. I mean, it can make music, it can make art, it can make creative works, writings. It can make screens. I have a friend of mine that's actually been working on screenwriting, and he's actually been in the film industry for a couple of decades. And he's actually coming up with a script, and he's using AI to help him come up with new thoughts and new ideas and kind of plot lines and all kinds of crazy things. And it's actually writing a bunch of the script. I mean, not all of it, right? I mean, it's kind of giving him like a base based on what he tells it to do, mind you, right? So it's still kind of very interactive. It's not just straight up just make me a movie or make me a script. It's not that simple. He still has to interact with it and produce a lot of this, but it saves him hours of handwriting a lot of this stuff. And he can go in and kind of add his own flavor to it and his own feel and still make it his, but he's using these tools to really kind of advance that. So lots of things you can do with this. Okay. We talk about discriminative AI models. That's kind of like your traditional ML and things like that. Basically classify or predict outcomes. That's kind of been around. We've been doing that for some time. As I mentioned, I got kind of into the ML landscape specifically because of security, right? And so we wanted to be able to predict things like everything from predicting potential fraud with banking customers of mine, where we're predicting whether or not a particular transaction might be fraudulent, right? So that's really kind of yes or no. Yes, this is fraud, or no, it's not. Okay. Or putting something in a group, applying it to a group, labeling images, saying this image is a scene outdoors. It's got it's daytime. It's got a bird in it. It's got a human in it. It's got a ball. Whatever. So again, I do like object recognition and things, but really, if you think about it, it's each object is its own thing, and so it's really just identifying that one thing. It's not doing anything creative, and that's stuff that we've been doing for a while now, probably going on a good decade. We've been having no problem doing that. About 2015, just a little bit further back, a little bit more history here. And 2015 approximately was a breaking point where AI, specifically deep learning, attributed to there's this test that happens. It's been going on every year. More recently, I don't know if it's continued to happen, but it went every year for quite a few years, called ImageNet, and you can go look it up. But basically, the idea was you have 1 million images, and there would be 1,000 possible categories that could be chosen. And in some cases, you might have images that have many things in a single image of those 1,000. And they would compare human beings to AI. And at about 2015, AI surpassed the accuracy rate of the human beings, and it did it in a fraction of the time. So that was the break point, 2015. And so this is where things started really accelerating, right? Higher accuracy and faster. Why would you have human beings going through images and saying that's that? It doesn't make any sense. So yeah, it's I'm just looking at the chat here. Generative AI method of using deep learning as its engine that produces. Yeah. So it's all about algorithms and predictability and stuff. So if you think about it, the way it's generating new work, it's still looking at past data to do that a lot of times. But what it does is it understands, here are all the different imageries and different things that it might be based off of. But a lot of times, if I were to equate this to something, it's a little easier to talk about. If I equate this to something like text, as it's writing a novel or something, it has to look back on what it's previously written and make predictions about what should come, right? So word after word after word, or even thoughts that need to occur and so on. And so it's all algorithmic based at the end of the day, right? Computers aren't magic, even though that quote from the Space Odyssey would kind of say otherwise, right? It's not actual magic. There is an algorithm being applied here. And so these algorithms have really enhanced things over the years. And so it's basically able to circle back and look at what's previously been written to kind of understand context and context clues and things like that and project what should come next. That's the general idea of what it's doing. Okay, we can get into the really deep dives if we wanted to, but that's not for this session. Okay, and so it doesn't need to be trained on it necessarily. There is a training process. There is a whole training process, but then new stuff that comes in, it can actually analyze new data and predict new things. And that's the thing about generative AI too, is you're able to kind of provide it information. So the base training, let me explain what I mean by training here. We'll talk a little bit more about this. But I can train on a bunch of data as a foundation. In fact, we have what we call these foundation models. I'll show you a little later. But foundation models are basically, think of them as like programmers' libraries. I don't know if whoever here might be a programmer or kind of do anything with that at all. If we had to work from scratch on everything we program today, we would be reprogramming things from the 1960s, and 1970s, and 1980s. It wouldn't make any sense. Well, we have these libraries as programmers, right? So this idea of programmers, they have these libraries of things that have already been written, decades and decades of work, that sometimes all I have to do is just reference that library, one line in my code, and all that past work is able to be leveraged, right? That's what's going on with ML now. That's what's going on with generative AI and all these things, is we're able to actually leverage past models that have been derived or developed. Let's say a model that's built to identify images might be leveraged to create new images, if that makes sense. It's already been trained on past images and already been trained on maybe unlimited amounts of works of art and so on, and use that as a way to now make a new model that actually has that knowledge, and it can now use that to produce new works of art. And that's the general idea, is we're able to kind of innovate one on top of the other. Okay, so it's kind of a stepping stone kind of process. And so you have these base foundation models, things that are designed to do simple things like text to voice, voice to text, models that are designed to produce images from text. So what it does is it first has to understand your text. Once it understands your text, then it's able to actually produce new text, right? Annie, I'm sorry, has a raised hand. I'm not sure. Go ahead, actually. I don't want to open the mics up too much for 100 and some odd people. You might have to actually ask your question in the chat or in the Q&A, actually, if possible. Whoops. Not sure what's going on, actually. Was that? Well, I'm not sure if I'm missing something here. Okay. Anyways, I'm going to move on. If for any reason there's a problem hearing me, or if there's any challenges, I don't know if everything's working. You can go ahead and mention it in the chat if there's something going on here. But in any event, I'm kind of on that idea though of being able to build our work off of past work. That's the whole thing. So we don't have to constantly train it. Okay. There are tools that again already understand speech, as an example. So I can just talk to it, and that new model I produce doesn't actually have to leverage that. I don't have to actually train on speech. I don't have to actually train on voice, because that's already been done. So now I can maybe incorporate that into a larger application that already understands how to do voice to text, and my programming code can actually allow you to talk to it, and I can now interpret it as text input. Those are the kind of ideas. Like there's these layers of models that we're going to leverage. So just quick check-in. You can hear me okay? Just put something in the chat if somebody would, just make sure audio is working okay. Something looked a little weird to me in the Zoom interface. Just making sure. Okay.
I can hear you great, Ryan. Just by the way, I can hear you great.
Great. Okay. Good to hear. Good to hear. Just kind of my Zoom interface shifted, did something weird. Okay. So in any event, all good. So in this case, generative AI models basically, again, can produce completely new forms of work. It might resemble, again, I want to point out, it does resemble, or might resemble some previous works. And this is where things get really interesting and sometimes a problem for us, just to be aware. So there was actually a case. I don't know if anybody's followed this or not. I don't have the actual case, the direct case information in front of me here. I didn't grab it. But there was a situation where an attorney quoted a court case, right? So attorneys do this all the time. They will reference precedent, right? They'll reference previous cases and decisions on previous cases. This attorney had actually used ChatGPT to actually produce some research, right? So you can use these tools to research, and it responded with case information and case details. And so the attorney actually used that information in the case. Turned out the case never happened. It was completely made up and fictitious. It was what we call hallucinations. So AI is still at this weird stage where it can have what we call hallucinations. And what those hallucinations are from is it saw a bunch of past information, and it's kind of predicting, it's making up new creative work. And so there is a tricky way to use AI in that sense. I might have to tell it to supply me quotes or supply me sources and things like that to make sure I can force it to not hallucinate if I am using it as a research tool, as an example. Okay. So bottom line, we're not at the point yet where we can 100% trust AI. Okay. I want to make sure we're aware of that when you go to use these tools, if you go to use ChatGPT or something and you do some personal research, you want to have it, educate you on something or whatever, you're going to want to cross-reference and maybe do your own, follow-up, but at least it can kind of get you, 80% of the way there. Just know that not everything it says is going to be completely true necessarily, because it is creating new pieces of work, right? That is kind of the whole thing about generative AI, okay? Yeah, it's hard to say, Paul. Do you trust humans 100%? Right? That's an interesting question, because like I said, as of 2015, it was more accurate than humans, okay? And that was almost a decade ago now, if you think about it. We're in 2024. Right? Exactly. I don't trust humans either, right? So the question is how much, at some point we have to put trust into people doing things, just like we might have to put trust into these tools. Are they ever going to be 100%? Probably not. I will tell you though, there are AI models being used that people's lives are in the hands of the model, right? Everything from when you hop on an airplane, right? There's actually AI being leveraged. Your electric vehicles that are out there's AI being leveraged. To self-driving cars, AI is being leveraged, right? All that stuff. And so when those models actually have to happen, those obviously the training process is taken a bit more seriously. I'm not saying we don't take training seriously, but obviously there's extra layers of things we can put in place, things that we can do to say, look, there's going to be a different degree of AI. When I am doing a marketing campaign, if I don't get it perfectly right, I'm okay. And I might want to just get that campaign done and out of the way and move on. Meanwhile, if I'm making something where, lives are on the line, I'm probably not going to accept a very low error rate, right? Or very high error rate, right? In that case, I want to make sure I'm very, very accurate. And that just means maybe more work has to be put into it. More resources have to be used to do the training, more data to actually make as accurate of a prediction as possible. When it does predict stuff, as an example, we are using, medical system is using this stuff to help us predict cancers and things like that today. That's very powerful stuff. But it doesn't mean we just say, oh, wait for the system to tell us that somebody has or doesn't have cancer. It just may be a signal to say, go look further, right? And so that's kind of the whole thing. We're not going to just put it all in one model and say that's it. Okay. So I'm going to show you some live stuff here. Okay. We're just kind of talking big pictures, and then we're going to do some demos. We're going to kind of show you some things. So in this case, these are a couple of the key developments leading to the GenAI environments. So we have what we call GANs, Generative Adversarial Networks. I can never say that for some reason. Basically, this is the idea of, we have what we call a generator and a discriminator. So the idea is one system and another system work in tandem with one another. One is generating the content, the other one is discriminating the content, and basically looking at it and comparing it with real data and saying, this looks like what it should look like, as an example, right? So if you're talking text, there's a lot of text generation happening today where, again, let's say I'm making an article or a white paper or something. I might use AI to help me generate the bulk of that content. Well, if I'm doing that, does it sound good? Does it sound like a human wrote it? Does it sound like a computer wrote it, right? And it used to be, not that long ago, like just a year or two ago, a lot of these generated contents, you could read it and go, that sounds like AI. Okay. Today, you won't know the difference if it's a good system and the prompts were good. And so in that regard, part of this is that discriminator comparing against real data and improving itself on a regular basis. It's always getting better. Right? It's always learning to say, look, what we generated is not right. And compare it with real stuff, and it doesn't sound right. It doesn't have the same flow. It doesn't, all of those things. A little note on this, going back over a decade now, Google actually has like an AI assistant that'll make phone calls for you and book appointments, call places and book appointments on your behalf. And people on the other end don't know that they're getting a phone call from a computer. And what's interesting is it even injects things like pauses and breaths and ums at times, things like that, to make it sound more human-like. And what's crazy is you could be on the receiving end of this. Maybe you're booking a reservation at a restaurant and you answer the phone. That person answering the phone may be actually talking to Google, and they've been doing that for 10 years now, approximately. So that technology is not new, and to just think that the stuff that we've seen the last couple of years has amplified that many times over. So then we have what we call transformer-based models. If you've heard of ChatGPT, the T in ChatGPT stands for transformer. And again, these were actually coming from that white paper back in 2017 that we mentioned earlier. So then we have these concepts of foundation models. And so this is what I was referring to a little bit ago. Foundation model is kind of like a library for AI. And so the idea here is, again, you've got models that already know how to do certain things in a smart, intelligent way, and we can leverage those in our larger applications and not worry about having to train on that fresh every time, right? So we're no longer at this phase in AI where we're having to just, it's all about having the data available to us. A lot of times the data has already been not only made available, but already been trained on, already produced models to do that work. And then we can incorporate that into a larger environment. And that larger environment might use not just one model, it might use hundreds of models to do what it does. When we talk about a model, the word model in the machine learning sense actually means the trained algorithms, and the basically it's the brain. It's like if you could package up your knowledge into something programmatic, that's basically what a model is. Okay, that's kind of the big picture. And so a foundation model are typically used for layers of things. Again, if I've got something that's a voice control, if you use like Siri on an iPhone, or if you use OK Google on Android, or Alexa or Google Home, or any of those, right? Those are voice systems. Well, they actually are using voice to text behind the scenes so that the computer systems receive text instructions, which it can work off of a whole lot easier, right? J, SME, just quantify the acronym, because there's a lot of SMEs that I know that could mean. So clarify that for me. But a model is basically a trained algorithm. It's the knowledge, right? So, okay, yeah, so that's kind of what I was thinking, like a SME, right? Though a lot of people know SME as being a subject matter expert. By the way, like I said, that's one of the problems, is the acronyms today overlap in a lot of areas. So in the case of this, yeah, it's kind of equals an SME. Yeah, you could argue that. You could argue that it's your subject matter expert on that thing, right? That thing that it's been trained on. And so when somebody makes, as an example, voice to text, it's been trained on probably hundreds of thousands, if not millions of hours of voice, right? To be able to interpret voice. And as you can imagine, take these systems that we're talking to. Let's say you do use Siri, or you do use these things. As you're speaking to it and it has problems, these systems behind the scenes are actually able to use that voice interaction to then turn around and learn from it and understand what it got wrong so that it can get it right later. So we actually are constantly refeeding in information to improve these systems. But that's just one piece, is, let's say, voice to text, right? That's one layer in that whole mix. And so that would be layered in with other things, like if I asked Siri to just play me some music, like what music should it play, right? Well, maybe it decides to play me something that it thinks I like, right? Well, that's a whole nother model that's different than the voice to text piece. And so there's all these layers, and those layers are a lot of times provided in the form of what we call foundation models. Okay. But for foundation models specifically, when you hear that term, a lot of times we are referring to generative AI, which is again used for creating new content of some sort. And so that's kind of the general idea there. So there's this product out there called Hugging Face. So I didn't actually have a poll set up for this, but I got a question for the group here. How many of you are familiar or have used or even just heard of GitHub? GitHub, and I'll put it in the chat, spell it out just for those of you, right? GitHub, okay? If you've done anything with code, if you've ever written anything as a programmer, in today's landscape, you've probably heard of GitHub. Okay. And yes, I'm sure a lot of you probably use it every single day or use something like it. Maybe you have your own Git repository or whatever. Okay. Well, the point is for those that aren't maybe familiar with GitHub, it's just one of many products. I'm not, advertising GitHub or anything like that. I don't have any ties to them, but they're a place where I can store my code, my programming code, and I can version control it, meaning I know every single modification that's happened along the way. I can hook in automation to it. There's all kinds of crazy things you can do with it. Well, what GitHub is to code, Hugging Face is to machine learning models. So what happens now is there's an era of machine learning models that have been produced. Again, a model that can, again, deal with, using the most basic example of voice to text. Okay. You don't need to create that, but you need to go find it. You need to go get that model if you want to use it in your application, perhaps. Well, there's now a repository that exists out there of these models. Many of them are free. Some of them are commercial. Okay, so some of them are licensed. Some of them require payment. When I say that, it's not the old payment model of I'm gonna fork over a whole bunch of money up front. Most of these, if you do have to pay, you're going to pay to use it, meaning maybe each interaction. So therefore, you don't have to come up with $100,000 or whatever. You can just use what you need. Yeah, sure. There you go. Blockbuster. That's an old reference. Oh my gosh. Are you talking about like Blockbuster Video, the old movie place? You can go rent what you need to rent, right? Yeah. Maybe in today's terms, maybe it's more like Netflix, right? I can just go watch a movie as I want, right? Just go find it on there and off you go, right? Now, I would say maybe Netflix isn't a perfect example because you've already paid kind of just a monthly subscription fee. But in this case, you might pay for each model potentially, depending on the model. Different companies make different models. In other cases, some are completely free to use, right? Many are completely free to use. But yeah, it's a use it. You pay for it as you use it most of the time if you are going to pay. Yeah, there you go. More like a Redbox rental. There you go. Or an Amazon Prime or something like that where you actually pay to watch it or pay to use it, right? That kind of thing. So it's pay to use basically. If you are paying for it, it's pay per use, not just come up with this huge investment to say I want access to this. That's the thing is some of this stuff was available a long time ago, but it would have been very, very expensive for you to either get the hardware for it or anything like that. So URL to ML GitHub type. Yeah, so that's what I'm getting at. It's called Hugging Face. That's the name of the product. I'm going to show it to you here in a minute. But if you literally just go do a Google search for Hugging Face. AWS does not own Hugging Face, but there is a tight integration with them. There's a really good relationship. Hugging Face chose AWS actually as their core partner, if you will, in running models and using them. So I'll explain that and I'll show you that here in a few minutes. So again, this is a model. We call it a model hub. It's a place where there's all these models just sitting out there that we can use. And by the way, in a lot of cases, you don't need to be a programmer at all to actually be able to leverage a lot of this stuff today. That's what's really cool about cloud technologies, about a lot of these tools that are available. We can just go use them and not have to be a programmer to do it. And if we are a programmer, we can save ourselves hours of work, if not even weeks or months of work of what this used to be, right? It used to be people would kind of, the companies that had access to this stuff were special, right? And they had a huge investment, many, many millions of dollars. But now we're in a realm or even your super small business right down the street. Maybe your local small business restaurant that's just family owned, single restaurant. They could be using this stuff and be coming up doing this to make their own marketing campaigns. You don't have to go out and spend a ton of money on marketing. They could use this stuff to predict, the more traditional ML, use it to predict inventory and things like that. They could be doing that in the cloud and not have to pay, but maybe even a couple pennies, to be honest. In some cases, some of this stuff will literally be pennies to do. And that's just crazy, or free, or completely free at times. So it'll work across platforms, and there's all these environments and stuff that are already produced for us. So AWS, again, AWS does not own Hugging Face. They are completely different organizations, but there is a very tight relationship here. I'll show you Hugging Face here in a minute. Okay, but bottom line, there's a bunch of tools that are tightly integrated. If I'm in AWS, some of the AWS tooling that's out there, and I choose some of the integrated stuff in AWS, if I click deep enough, it'll take me back to Hugging Face in a lot of cases, and vice versa. I can be in Hugging Face and say, I want to run this model, and it might take me to AWS, Amazon. By the way, I've kind of assumed that some of you might already have a cloud knowledge. Just high level here. If you didn't know, AWS, Amazon Web Services, is Amazon's prime business. I shouldn't use the word prime there. It is their core business, actually. Amazon makes more money supplying servers and infrastructure to companies than they do selling products on Amazon.com. Ironically enough, Amazon.com today is basically their side business. Amazon AWS basically runs the world. We use Netflix. I used Netflix as an example a few minutes ago. Netflix runs 100% on AWS servers, if you didn't know that. So Amazon is running Netflix when it comes to an infrastructure and hardware perspective. Okay, so if I want to go use machine learning work, if I want to go use machine learning technology, I don't need to spin up really expensive servers anymore, right? I can just go use Amazon servers, or you can use others too. You can use Google or Azure, but Amazon is definitely the big one here because Hugging Face chose them over companies like Google for some very important reasons, and specifically, it was just their breadth of options available. All right, and their sheer size, quite frankly. So let me actually show you this. So I'll just show you Hugging Face's interface here. So this is Hugging Face. I know some of these names that we see in these technologies today. It's kind of crazy. Yes, Hugging Face is actually a product. Okay, I haven't just been making something up here. Okay, that's its name. All right. So that is the name of the product. You'll see here it's huggingface.co. I'll put this in the chat just for anybody else that wants to join along. If you can get a free account here. You don't have to pay anything to create an account. It's a good idea to create an account because you can do things in here when you have an account that you can't do without. But if I come in here and go to models, which actually those are my following models up here in models. Okay, my account here that I'm using is just for demo purposes, so I don't really use it on a regular basis. So it doesn't have a lot of stuff populated. But if I go to models here, look at this, over 500,000 models available for us to use. So these are things that big organizations have been getting lots of popularity around, and we can just go use their models, right? Again, a lot of cases it may be completely free. In other cases, some sort of a pay-per-use or however we might want to use it, right? But the point is you can kind of scale that and just basically spend as much as you want to spend. You don't have to go have this huge investment like we once had to do, okay? So if I come in here, I can sort by, different, popularities and things, most likes, most downloads. So this, there's this stable diffusion is really, really popular. And this company right here, Stability AI, has produced a bunch of stuff here. Okay, so this is, I just clicked into it. This is one of their models that they've produced, and I can just use this, okay? So you see over here, I can deploy it. So if I want to use this model, I can actually use Hugging Face's interfaces to actually run it and use it. I could also use Amazon. You see right here, this is SageMaker is an Amazon product. It's Amazon's like core machine learning or core AI tool. So this tool, SageMaker, will allow me to take this and run it in AWS right from here. It's actually a quite easy thing to do. it actually shows me the code. If I am a programmer, it would show me the code that I would need to use to basically plug this right into my application. And I can use AWS to do it. Okay, so this provides me kind of whatever I need to just make this happen. Okay, and so this particular tool, this particular model, I should say, produces images. Okay, there's a lot of different image models out there, and they have different behaviors and different quality of outputs. In some cases, maybe it's better at producing one thing than another, and so on. And so this is based on basically text that you can put in. In fact, let me see here. If I go to Spaces, let me actually do this. This is all within Hugging Face. If I go to Spaces and I find that same, there's actually a space for this. I'll show you what a space is here in a second. Let's go like most likes. Okay, Stable Diffusion right there. So if I come in here, Stable Diffusion, let's make an image. Now, I'm always leery about this in a live demo because you actually have no clue what it's going to produce. So this can actually be a little bit tricky at times. But let's give this a try. I was playing around with this earlier before our sessions to come up with some good prompts to play around with. But let's do this. Let's do a watercolor painting of the Dallas, Texas skyline. I'm in Dallas, so I figured, hey, why not? Dallas, Texas skyline using Van Gogh's Starry Night as inspiration. So this is just something I decided to write. Okay, it's just something I came up with all on my own here. Just playing around with something I want to produce. So I'm actually I'm going to make an image here. And this will produce me something unique. I want to point out it is not copying other work, but it's got probably thousands, tens of thousands, hundreds of thousands of pictures of the Dallas skyline that it knows about, right? It's got, now, is it always going to be right and accurate? Like I said, it's subject to errors. I mean, could it incorporate some building in this picture that's not even in Dallas? Could it plug in something from New York or something? Absolutely, that kind of stuff is possible. So you have to kind of inspect it, right? But I like this one. This was again, I didn't know what it was going to produce. Okay, it's unique every time. And so here's one I like that. This kind of looks like the Space Needle to me in Seattle, but we have this ball, this building. I forget the name of it off the top of my head, but in any event, this is actually producing completely unique works of art. And somebody might see this and look at this. This one looks like it's framed and it's got this it looks like it's sitting on a desk or something. This one looks like it's sitting somewhere on a wall. I don't know. That's all AI driven too. Okay, it's not like it's just found an image on a Reunion Tower. Thank you, Andres. It was escaping my mind. But an image like this, it's not like it just found something on the internet and just is just showing it to us. Okay, this is a unique piece of work. Okay, I just need to point that out. And so this is just a way to kind of sandbox this or play around with it. Are there products out there that productize this? Absolutely. I can do this in ChatGPT. I can do this in Google's Gemini. A lot of these products now I can generate images. Well, guess what? Behind the scenes, it's not ChatGPT or Gemini doing it. It's using models that are already incorporated into it. In fact, in a lot of cases, it's using Stable Diffusion to do it. Okay, so what happens is you can take this product and you can make your own application that embeds this into it. And you can have this capability in your product if you want. Right? You can be a programmer and you can actually embed this technology into your own applications. Okay, and so that's exactly what those third-party companies are typically doing. Is they're using a model. Now they've usually done they're incorporating a lot of models, and maybe they've supplied it a whole bunch of its own data. So what I can do is I can take a model like Stable Diffusion or anything else, and I can actually enhance it for my own use. This is where things get interesting. Is, like I said, this product here is basically text to image. Okay, that's what it does, text to image. But it may not be fully trained on every image that's ever been created, right? So what if what if I want something a little bit more unique? Maybe I need to create images of things that are very niche to my market, and my industry, my business. I may want to supply it more data and more images to enhance it. And that's where I can take these and use this as what we call a foundational image, or excuse me, I'm sorry, a foundational model, and use it as a basis to then make my own. Okay. Who owns the rights of the image generated? I would argue it depends on the product. Okay, that's a licensing thing, depending on the model. So you do have to read this model by model and how the licensing works for that. But that is where it's at the end of the day, it's yours most of the time. You paid to use the model, but the production of the model is many times yours. But I'm not going to promise you that. Okay, it's all going to come down to licensing. So do read the licenses. Okay, so in that regard, if I come back to just stable diffusion in general, let me go back to models. I'll show you the licensing here, just show you where to find that. So if I go back, if I go back to this one's by Stability AI, Stable Diffusion. If I come in here, you'll notice in here there's all kinds of links and information, right? And so inside of here, there should be a link to its licensing. There's files and versions here, and I believe the license is usually in here, right here. So if I click on this, it'll tell me exactly the licensing for this model, okay? So go ahead and use this information to answer that question, right? And I know it's a lot to read through, but that may be a legality thing there as to the models you choose to use. You might need to know how you can use those and things like that, right? Now, if you use a tool like ChatGPT or others, it may have its own published licensing as well. So just kind of be aware of that. So you have a model licensing, and then you've got any software that might be leveraged might have its own as well. So licensing can get a little tricky here, okay? But keep in mind, it is new creative work, right? It is new stuff. So, but it can get interesting. There have been, I think the courts and the laws and all that, obviously, I'm not a legal representative here, so a little disclaimer, but they're still deciding, right? There's still a lot of stuff that hasn't been decided on this, and I'm sure things will come up over time. Well, that's just kind of where we're at on this. So if you were to use it and publish it as your own work, that's going to be tricky. Most of the time, though, doing it for things like marketing or using it to make predictions on things or what have you, you're usually pretty safe doing that. But it's when you actually publish it as your own creative work and you're making money off of it. If I were to turn around and sell a piece of art that AI makes, there's probably going to be stuff I'm gonna have to look into there, right? Yeah. So Dinesh, that's a great point there as well. So yeah, sometimes there are things in there that says, hey, look, we'll indemnify you because there is that hallucination aspect of things. There is the fact that it learned from something. So can it produce something that looks very similar to an original? It could, and that can get tricky. It can get very, very tricky because if it is producing something that is 95% similar to something else, you do have a situation there. So you want to make sure that you understand each product, each tool that you might want to use, and the licensing behind it, and so on. But that's a big question. That's far beyond what I can answer today for you. Right? So that's Hugging Face. Okay, so this basically is a huge repository of models available for consumption, available for use. And then the next thing is, what if I want to take one of these models and I want to train? On top of it. Okay, so what I can do is I can come in here and go, okay, stable diffusion. Look at this. I can do my own training. Now, training, it depends on the model. Sometimes you'll see this drop down and it'll say this. In other cases, it'll actually say SageMaker and AWS. So it kind of depends on the product. Let me show you, just see if I can find an example of that. I made a note for myself. Yeah, there's one that I know. Okay. So if I look at this, I think it's this one, Zephyr. I go train. Yeah, so this one right here, there's SageMaker. So what I can do is I can actually say, I want to do a new training job. I want to, when you see the word train, it means I want to supply it data of my own to improve it. Okay, that's basically what that means. And so in that regard, I can do fresh training jobs based on this model. So I can use this as a starting point and enhance it for my own use. But the most basic principle or basic understanding around that, improving it for your own use, might be industry specific, might be business specific. Let's say I am a manufacturing company and we manufacture parts for some hardware product. And so there's specialty bolts and tools and brackets and all that kind of stuff. We might actually use AI and cameras to actually be able to identify those parts within that ecosystem, so it can just see it and tell you what that part is. And that might be done on some sort of automated pipeline, some sort of automated production line, right? But that's even more traditional AI. That's actually not generative AI. That's kind of things that we've been doing now for quite some time. But so that's the thing too here. It's on Hugging Face, the models that are here, these are not all generative AI. Okay. I'm sorry, keep doing that. This model up here. These 500,000+ models are just models. Some of them are more GenAI specific, where they are producing new work. Others are more about identifying, categorizing, predicting fraud, anomaly detection, simple stuff like voice to text, text to voice, which have actually we've been doing that for quite some time. I say simple, but it's just simple because it's been done for a long time. It's not new and unique necessarily. So yeah, this is where these models, there's a massive library here, right? Now, if I go into AWS also has some of its own models, and I'll show you that here in a little bit as well, okay? So there's this product called SageMaker in AWS, and SageMaker is Amazon's core technology that allows us to create models, train models, host models, run models, create applications that integrate with it, and so on. Basically, everything ML that we want to do, we can do pretty much in SageMaker. That is for custom work, right? Custom, and or if I just want to run a model. Okay, SageMaker has the ability of just simply running a model somebody else produced, all the way to I want to completely make my own custom models altogether, starting from scratch or using other models as a starting point. Right? All of the above. So there's tools in SageMaker. There's a tool in here called like Data Wrangler as an example. This allows me to manipulate and work with data that I'm going to use for training, and zero code if I want. I can use code to do things if I wish, but I can also just say zero code. Here's what I just kind of tell it what you want to do with your data, and it will structure the data and kind of get it into a point at which it's ready for training your own model. Okay, training your own model basically means here's all my historical data that I want to use, and I want to use that for future work. And so Data Wrangler would be a great tool to help us with that. Okay, and that's just one feature of SageMaker. So obviously we can't teach you SageMaker in the short time we have together. In fact, we're kind of getting closer to the end here. But SageMaker is not one product. Okay, SageMaker is a whole suite of products of its own, and this is in AWS. And so, as an example, it's got a product called SageMaker Training, and that product, all it does is trains models. That's its sole purpose. Then there's another model called SageMaker Endpoints. I'm sorry, another product called SageMaker Endpoints. And what that will do is allow us to host a model and allow us to programmatically work with that model that is now running. So SageMaker's got a lot of these different elements, and we don't have to pick one or the other. We can say, you know what, if I wanted to train something in SageMaker, but run it in Google, I could do that. The outputs of these models are not proprietary to SageMaker, okay? So if I build a model anywhere, that model is universal. That's why Hugging Face works, because you can just create models in any system. I could go create a model in Google, create a model in Azure, create a model in AWS, doesn't matter. The model that I produce, I could go put on Hugging Face and make it useful, make it usable by anybody I want to make it. I could make it private, I can make it public, but I could just use SageMaker just for the training piece if I wanted. Or I could use SageMaker as a way to run a model that somebody else made at some other point in time, right? So it's got a lot of specialized tools built into it. We're not going to get into all of them, but it's got some geospatial work it can work with. SageMaker is a plug and play kind of tool if you want it to be, and all the way to people that are have a master's in data science and want to write their own algorithms and want to do everything all the way down to the lowest, deepest level you can get, you can use SageMaker to do that too. Okay. Yes, SageMaker is designed for ML. That is its sole purpose. The whole product suite is all ML, and which includes generative AI, right? And deep learning, and just more traditional ML. All of the above, SageMaker will work great for. Okay. It'll manage the entire pipeline, by the way. So something that a challenge that AI has in general, okay, is this concept that's in slang terms people would actually say model rot. That's a term I've heard. I've never really liked that phrase. I don't know if anybody here has heard this or not, but the idea is also what we call concept drift is another term for it. So the idea with models, one of the problems with it is a lot of times they're built with current data knowledge, right? They're built with some sort of inputs. Well, those inputs change with time, right? Think about it. I was using an example of, let's say, retail companies wanting to do a marketing campaign or purchasing behaviors. Let's kind of focus on purchasing behavior for a second. And you have this retail company that was pre-COVID. And then COVID rolls around and everybody's getting locked down. No travel is happening. Everything changes, right? Everybody's doing things remote. They're not going to the store anymore. And so what happened just now at that point is the model's effectiveness basically degraded almost overnight, right? It was trained on some information and current information that was about purchasing behaviors or customer behaviors. And then those behaviors changed. Well, that's the whole thing about models is the way models are built is they're built on the environment today, right? And that environment around the model changes. And so as the world changes, the model has to be updated. And so a lot of times these models, you'll notice if you go to Hugging Face, you'll see a lot of this stuff. You won't see models that were updated, 2 years ago. Okay, that's pretty rare. There might be in here out of these, 500,000 or whatever, but most of these models, they're updated very regularly. And the reason that they're updated very regularly is they have to be, right? You want to use current information to make them as accurate today as possible. So they're constantly evolving, okay? So there's new versions. Well, the reason I bring all that up is SageMaker is built to actually monitor the quality of the model. It can automatically develop an entire automated pipeline that will monitor the model and produce new data or collect new data and retrain and make that model a fresh model and automatically produce it and host that new model. It'll do that automatically. That cycle will happen in an automated way. And so I can kind of set it and forget it if I want and let that model work just happen automatically. SageMaker will do all that. Okay. So again, SageMaker, you can build models here. There's a product in SageMaker called Jumpstart. And I should say that's a feature of SageMaker called Jumpstart. What Jumpstart is basically a bunch of stuff that's already been done for you, ready to go. So it's a bunch of models basically, but it's more than that because Jumpstart can actually include automated pipelines and things around it, not just the model itself. But it does have a hub of foundation models that you can tie into. So you'll notice in Jumpstart, in SageMaker, a lot of these reference back to Hugging Face. This is that tight integration between Hugging Face and AWS. So if I go into AWS's SageMaker, I'll be able to find models and stuff in there, but a lot of those models are sourced from Hugging Face. Okay. So in Hugging Face, so I want to point out there's a question here about the difference between models and spaces. A space is more like a collection. In some cases, a collection of models, while a model itself is the actual entity, or the actual tool or library that we're basically using, right? So that's all it is. Spaces is just and Spaces is a place where I can actually kind of play around a lot of times. A lot of times in Spaces, I can actually use the tool, like we saw that, right? Model. So the model is actually the trained knowledge. Okay, that's the raw model is a bunch of algorithms and stuff. Okay, it's the results of the training process. It's the results of it going through and looking at all that past data and producing some knowledge. That's what the model is. The model itself is not runnable, not directly. The model itself is the brains and I have to have some sort of software to run that model, right? I have to have some way of actually running it and hosting it and making it useful or usable. Okay, the model is actually just the logic. Okay, so when I go to Spaces in Hugging Face, let me go back to that real quick. I go to Spaces, and in Spaces we've got. Let me just. We're going to get short on time here. I pull up that same Stable Diffusion space here. Right. In this space, what it's done is it's actually taken that model and hosted it and using it so I can kind of play with it. It's a kind of what we call like a sandbox, basically, a place where I can leverage that model. So the model itself is actually just the brains, the actual learning that's been done. But then the space in Hugging Face is actually a place where it can run and I can explore it. I can play around with it. In this case, a bunch of different prompts that you might put in for Stable Diffusion demo here. That's part of the space. Okay, so that's the main difference between the two. Space is a way to run it and play around with it. Okay, so let me just briefly show you SageMaker. As time's kind of getting tight here. So model training and deploying at scale. Just real quick again, I can train models in SageMaker. I can run them. I can host them. So for like production use, right? The Spaces is not really for production use here. This is a way to kind of demo it, explore it, and whatnot. But in production, I'm going to have it running somewhere, right? Yeah, and then of course you can also use Transformers library and things like that. Randeep actually mentioned that. So this is I'm not getting into the deep dive. Obviously, in 2 hours we can only go so deep. But yeah, you can work with the models from Hugging Space. And the nice thing is though, I don't even have to do most of that. With SageMaker, I can go into Jumpstart and use those models right now, right? So in an actual production state. So I'll actually show you that here. Actually real quick. So SageMaker Jumpstart right here, there's a whole bunch of models available. I'll just show you these firsthand. So let me actually show you that. So SageMaker. Make sure it's still logged in. Okay, I logged in ahead of time into my AWS web console. So this is in Amazon Web Services. This is the SageMaker product. You can go to whatever products you need to go into. But if I come down here, you'll see there's this Jumpstart and these foundation models here. And look at that, Stable Diffusion. This is one of the most popular models, by the way. That's why I keep using it. And it keeps coming up like at the top of the list. It's just very, very popular for image generation. Again, you want to create images for, I don't know, maybe you want to generate logos, right? You want to generate even pictures for like was I getting at like headshots or something, right? And like, so maybe I've got a profile I'm setting up and I want pictures of me. I mean, there's ways to actually like make those a professional looking image using your pictures, right? Using pictures of yourself to generate a new professional image that used to take, photographers, days and weeks on site, and have to go. They have to do all kinds of work to manipulate the images and get it right. And now you can use these tools to just generate that stuff. There's productized tools out there to do that. And so in any event, you see this model right here. If I view this model, I'm in AWS, I'm in SageMaker, and there's Stable Diffusion right here. And if I go back to this model card right here, I clicked into it. This model card, look where it takes me, right? You see how there's this really tight integration between Hugging Face and AWS. And so specifically, AWS was, again, chosen by Hugging Face and said, look, that's who we're using. And so they came out and did all kinds of press releases a couple years back around that. And there's a deep dive integration there. And so that's again, these are those foundation models we were talking about, right? So Jumpstarts in SageMaker are a way for me to kind of, again, just jumpstart, be able to just get going very quickly and early with very little work. I can come in here to Jumpstart foundation models. I can take this model and I can choose to deploy it. I would actually have to choose to acknowledge the licensing behind it and the pricing model. If there is any pricing, the nice thing is if you run it in AWS, AWS deals with the billing. You don't have to worry about paying some third parties or whatever, right? It just kind of all comes through your AWS bill, and you can kind of see exactly how you're spending your money, what the costs are, a little bit cleaner and things like that. So I would have to subscribe to this here and acknowledge any kind of this actually is a lot of times a paid for product. Like I said, you don't pay one time for it in some big lump sum. You just pay, in some cases, fractions of a penny to use it each time. And it depends on how much you use it as to how much you spend, right? If it's for production use as opposed to development use, right? Those are all variables. And so, there's all kinds of options in here in SageMaker around using all these different models. I can choose whatever I want to do there. And there's a question about, can I use SageMaker for vision? Yeah, absolutely. I forget where that question was. Train vision ML, yeah, right here, right? Computer vision models, natural language processing models. There's all that. We've got things like, again, governance. I know some people have mentioned or talked about things like risk or security, things like that have been brought up. There's a whole bunch of stuff you can do around that. Here's the training tool right here. I can come in here and just do a training job. Now, I did one before class just to show you. So I did a training job. I want to show you this. This training job took me 4 minutes. I have some data that I fed it, and I performed a training job, and I produced a model right here in SageMaker, and it took 4 minutes to produce it. Okay. So in this case, if I scroll all the way down, I actually end up with a model package right here. Basically, I have this model. This is the file name, if you will, for it. Model.tar.jz is the actual output here. But I can take that and run it. Okay. In layman's terms, to define a model, it is the knowledge. Okay. Again, what is a model? A model is the knowledge. It is the brains. The definition is that it is a trained algorithm. So imagine, mathematically speaking, you don't have to be a math expert to understand this, but you take an algorithm. If you remember back from, without getting deep into the math, if you have an algorithm that's got all these variables, okay, you have to feed some values into those variables, and those values essentially help it make its predictions or help it make it do what it does. So an algorithm, you start with an algorithm. And then when you do the training job, it learns the values or the variables that it needs to use. And then the model is the result of that. So the model is actually saying, here's my algorithm with all this trained information. It knows now what kind of inputs and what kind of deals to, what to put into that algorithm. So basically, it's a mathematical computation at the end of the day. But that model, in layman's terms, that model is the resulting knowledge of what it's learned on how to do this stuff, right? So as an example, it's learned how to produce images. Okay, so we have these stable diffusion. It knows how to produce images. It's learned how to do that. That's what the model is the ability to do that. Now you have to run it somewhere. You have to use it in some software product somewhere, some application. You have to host it. And then what I can do is take that text input. I can say, create an image that looks like this, and it'll produce an output because it's learned how to do that. Okay, so it's the actual brains. We didn't get into the depths of it, but this concept of deep learning, what's built on deep learning, it actually uses brain terms, neurological terms. Okay, a lot of the terms that are used in deep learning actually rely on the way our human brain actually works. So ways to incorporate inputs and outputs, right? So in our brains, too far on this, in our own brains, when we see an image, when we look at something, we don't see that something like you think you do. What you do is you see textures, you see colors, you see some shapes, you see shadows, and there's actually different parts of your brain interpreting each and every one of those elements, and then your brain puts it all together. Well, guess what? The models behind all this stuff does exactly that. It's actually built off of the neurological understanding of the human brain. That's exactly how deep learning actually works, which includes generative AI. Okay, it learns the same way you and I do, and it actually interprets data the same way you and I do. It learns that, hey, when I see something that's textured this way, it's probably going to feel a certain way, right? And it learns the same thing. Okay, it learns. It has an input, and it kind of has an algorithm, if you will, that kind of says, here's what that's probably going to feel like, and then when you touch it, you realize it feels that way it looks. So that's the thing is we usually, our brains, and we have hundreds, thousands of neurons active at any given time. Well, same thing with deep learning. It's actually got all these little elements, and it's you have one element that's paying attention. If I'm doing an image, one element that's paying attention perhaps to corners and edges of transitions of color, right? Another one that's just paying attention to color. Another one that's just paying attention to texture. Another one that's just paying attention to size and relative size, right? Things like that. And so, these inputs and these outputs, and that's basically what's going on behind the scenes. Is in deep learning, you have massive amounts of neurons that have been built, programmatically, and they learn. And when they learn, they now know how to interpret that. And so that one little piece of the bigger picture, it knows how to do that one thing, but collectively it's hundreds of these little things. Okay. That's deep learning in a nutshell. That's a week-long class if we wanted to actually teach that. That's not something you learn overnight. And there's a ton of math involved in that. But if you want to just kind of talk high level, again, a model is the actual resulting knowledge of how to do something. That's the most basic way to explain it. Okay. A model is like a recipe. It tells you how to bake a cake step by step. There you go. Sort of. The cake itself. So yeah, that's an interesting one, right? Produce me a cake. Okay. It's not just a recipe. It knows how to make one cake over another cake over another cake. It understands how to bake. Okay. That might be a better way to put that. A model knows how to bake, but collectively it's a collection of hundreds of different elements that it's learned how to do that, right? And so it might be everything from temperatures to understanding chemical reactions to understanding how things rise to understanding all of that, right? So it's not it actually wouldn't be the cake. That wouldn't necessarily be the model. The model produces the cake, but also it's not the recipe either, because a recipe isn't dynamic, right? A recipe is fixed. So imagine if you were a really good baker and you had the ability of creating recipes that resulted in really good products, right? The model is the baker. The model is the knowledge that's required to do that. And it's like if you could transfer that knowledge. Anybody? I'm sure we've got some some movie goers in the house. If anybody here remembers the Matrix series, right? Remember when it was like, if anybody remembers that movie, that series of movies, download how to do something, right? Download that knowledge into your brain. That is a model. A model is how to do that action, how to do that thing. Again, how to convert voice to text or text to voice or text to images. It's some special knowledge that it knows how to do that thing. And that's it. Yeah. I know. Yeah, I agree. And again, layman it's a hard one because it's a very complex task. There's an old saying. I think I'm wanting to say it was Einstein that said it, but I could be misattributing it. But anybody can make something complex. It takes a real expert to make it simple, and that's true. This is one of those topics. It's like, how do you make this simple? It's not simple, but we can use it in a simple way today. And so that's the problem is knowing how to understand it in a simple way. We don't need to do all the underpinnings. That's what's kind of cool is the public cloud has built this in such a way where it does all the hard work now. It does all the heavy lifting. It does all the math for me. It does all that. And to fly the helicopter. That's what that scene was. That's right. So yeah, in this case, the heavy lifting of all of the data science that goes into it and stuff, if I don't want to do that, I just want to use the results of that, I can do that, right? That's the beauty of the public cloud is I can actually leverage all this very complex technology in a very simple way. I can just simply say, hey, I want to download that knowledge of how to do that thing. I don't want to actually know how to do it. I just want to use the knowledge. I just want to use it. And that's basically a model, right? I want to go use that knowledge to do X programmatically. Programmatically, I want to be able to use that knowledge. Yeah, exactly. So Stephen, I'm sorry, Seven. Yeah, basically, yeah. The model is the knowledge. So in this case, receiving the training, being able to then produce some work of art from that training, right? So again, it's like the baker learning how to bake, and then maybe even being able to produce its own recipes and then actually bake the cake, right? The model may not do the actual baking of the cake, right? That may be my software engine, but the knowledge on how to do it and how to make it would actually be your model. Okay. Yeah. It's a complex thing, but it doesn't have to be. We can actually use the model without knowing how to do everything the model does. Okay. I know it's a lot. This is where it's really hard to have a complex topic thrown into 2 hours. But just kind of giving you some insight into some of this. Everyone in this class is going to pick it up at different levels. Some people have ML training experience already and are already familiar with that, about 25% of you or so, or maybe 20%, I think it was. Others maybe have like ChatGPT or other experience in that realm. And others are just totally new to this whole topic. So it makes it tough also with a group this size and such a short time window. But you've all been wonderful. So actually, I do want to show you one final product, and then we'll kind of open it up for some final questions. All of the questions have been kind of getting answered, I think, hopefully along the way a little bit. There's another product called Bedrock, actually, in AWS. Let me go pull that up. Bedrock. Okay, Amazon Bedrock. This one's a confusing one for people because it is basically Hugging Face, but as a internal AWS application. So it pretty much does everything Hugging Face does for the most part. So a lot of people get confused as to why I would want Bedrock then, because, well, Hugging Face actually has more models. Hugging Face is like the de facto standard for model repository or model, model repository. So then Bedrock is actually a model repository in AWS. Well, ironically enough, this actually ties into Hugging Face as well a lot of times. The main reason we want something in the cloud provider is a lot of times the need to not go out of the cloud provider. So as an example, yes, by the way, Gilmar, everything in AI comes down to a model, 100% yes. There is some model that has some particular knowledge that you are leveraging, right? And now it may not come to just one model. It may be a collection of models. When you do something in ChatGPT, it is a collection of models that ChatGPT knows how to use and leverage, okay? So in any event, yeah, so Bedrock is a model repository of its own. The reason you want this, let me give you an example. Let's say we have a sensitive data situation. Okay, we've got personal information. We maybe even process credit cards. We've got some sort of sensitive private information. Okay, and then we want to do some sort of AI against that data. We may also have an environment on top of all of that that is not allowed to have internet access. Okay, I'm just kind of framing up the scenario. So we have this very tight, secured environment. It cannot get to the internet for security reasons. It's got sensitive information that I don't want to just go out wild on the web. I got to protect it. And so I might need an environment to govern that a bit more. Well, if I can't get to the internet, I can't get to Hugging Face. Okay. And this is the same problem, by the way, that emerges with things like ChatGPT. I'm sorry, excuse me. I meant to say GitHub. So like GitHub, same thing. It's not hosted locally in my environment. So in this case, if I've got a bunch of applications and software built in AWS, built in the cloud, and it needs to use these models, and I need it to be completely secured and locked down, I can't get out to Hugging Face no matter how much I want to. I may not be able to do that. And so that's a big reason to use Bedrock, because Bedrock is private to AWS. And now I can actually embed this in environments that normally couldn't get to Hugging Face. So to some degree, this competes with Hugging Face and also integrates with Hugging Face in various ways. But really, it's self-hosted by Amazon. It runs in Amazon. You're not having to leave Amazon to get some of these models. Okay, so this is an alternative to Hugging Face. I would say it's still fairly new. This product has not been around all that long. Hugging Face has been around much longer. Hugging Face has a much larger footprint, much larger adoption, if you will. So when this came out, at first it kind of confused me. Like, why do this? Because Bedrock what's the compelling reason to use it? Well, there are big compelling reasons, and it's usually around what I just described. That's one big reason. Okay. But just be aware, Amazon offers its own repository. In other words, I can do everything in Amazon and not have to leave Amazon to do it. Okay, so if I'm building up complex environments inside of AWS, I don't have to leave AWS to consume these models and deploy them and use them within my environment. Okay, so just wanted to make you aware of Bedrock. We don't need to go through it in depth, but just kind of be aware of it. So the main suite of tools here that kind of make up everything we've discussed today really comes down to AWS's SageMaker and Bedrock. And these are just some features here. Just kind of pulling them up on the screen. They'll be in the recording as well. And of course, you could read bullet by bullet. I'm not going to read bullets to you. You can do that for yourself. But the main thing here is, again, Bedrock has a lot of overlap with Hugging Face, though. Okay. So these are just some features. I'm not going to go line by line through them. Just want you to be aware of them. This way, they're also in the recording. If you go grab the recording after this, you can always pause it on these screens and see them for yourself. We don't typically share out the slide deck, but you'll see them in the recording. So I want to make sure they're in the recording here. So we don't need to go crazy into Bedrock, just a bunch of little slides with some bullets on them as far as some features and things like that. But generally speaking, we kind of went over the high level of Bedrock, and that is that it's very much like Hugging Face. Okay, so I'm going to leave these. This is also, again, this is where Bedrock adds the extra compliance. There's all kinds of bullets here around compliance standards and the ability to achieve those, where I may not be able to achieve those with Hugging Face directly for reasons described already. Okay. And then, of course, also Bedrock maybe adds some additional legal protection too. So this is that indemnity that was actually asked earlier, right? Copyright claims arising from this stuff. So this is where there's uncapped indemnity. That's kind of interesting, right? So another reason to maybe use Bedrock as opposed to Hugging Face. Hugging Face doesn't necessarily directly offer you this. This might be license by license. So this is another reason maybe to consider using Bedrock as well. Okay, so that's it. We've got a few minutes for Q&A. If anybody wants to throw some questions in either the Q&A box or in chat, either one, I'm paying attention to both. Let's see here, just following back on some of the chat comments here. If I don't have the need to train foundation models nor develop new models, yeah, you don't. So you will need a place to run the models, right? To actually produce them. So I showed you the sandbox in Hugging Face, right? It was actually called a Spaces, right? So I was able to kind of put a prompt in there and generate an image. But that's for like playing around with it. If you're going to use it in production, if you're going to actually incorporate that model into a piece of software, you're going to need a place to run it. And that place to run it can be a lot of places. You actually could use like paid hosting providers to run those models. You could run it in SageMaker. You could also go build a virtual machine and completely do it yourself. That's a lot of operational overhead. For most people, I would discourage that, but you could. So the point is you need a place to run that model and host it. So it's kind of like if you have a website. You need a place to host that website, right? There's hosting providers out there. You can have a website built on WordPress or whatever. You don't just have a website. You have to run it somewhere. Same kind of thing here with a model. I have to actually run it somewhere. It has to exist somewhere and have capacity applied to it and have the ability for it to do what it does. And so you might choose SageMaker to do that, but you don't have to, right? You could again run your own virtual machines. You could use a third-party hosting provider. I believe Hugging Face can actually be that hosting provider for you, but you may have to pay. Right? There's paid options within Hugging Face. So it kind of just depends on who you choose to actually run the model. Okay. Okay, cool. And I'm just looking feedback here. Yeah, you started kind of looking at Bedrock 2 weeks back. That's where you spend most of your time. Yeah, it's cool because, I mean, again, Bedrock does just about everything Hugging Face does, but because it's directly integrated in AWS, more so. Not that Hugging Face is highly integrated as well, but Hugging Face is not Amazon. It's not by Amazon. It's just a partnership. Bedrock is Amazon. And so you're also going to get better support in the sense that you have a one-stop shop with AWS where you can say, look, I'm trying to do this thing. I've got Bedrock over here, SageMaker over here, and you can use those things together and you're going to get full support on the whole landscape, right? Not just part of it. And then also, again, the legal aspect of it, not having to go out to Hugging Face is very helpful, right? Oh, yeah. So neural models. Yeah. So I am aware of the book. As far as anyone currently using, I mean, I couldn't point to specific references without doing some homework on it. But yeah, they're absolutely being used widely, in fact. Yeah. So I'll just kind of give you just a direct answer there on that one. Okay. We're about, I think we're about out of time just looking at further questions here if you have any. SageMaker to host. Yeah, you can use SageMaker to host, SageMaker to train, SageMaker to actually monitor the quality of the output of the model. So like, is what it's producing, is it actually what you want? Is it good? Just as a most basic example, what if I were to predict fraud with some regular ML model. Now, that's not generative AI specifically. That's just AI. That's just ML. But let's say I was predicting fraud and we're a bank, but 90% of what we predict as fraud is not fraud. And then turns out we're actually missing a lot of the fraudulent transactions. That's not very good quality, right? So SageMaker actually gives us the ability to monitor the reality of things where we can say, look, we predicted this as such, but we went back and inspected and realized it wasn't. SageMaker can help us monitor that quality and actually measure its success. So it's got all kinds of features. There's just a few. It's got the jump starts to give us the ability to kind of just get going quickly and use models just right out of the box and go. It gives me the ability to host those models. It gives me the ability to train new models completely from scratch or from foundation models and enhance them. It gives me the ability to monitor the quality of my models. Gives me the ability to have CI/CD pipelines built into all this. So I didn't even get into that. That's a whole automation for those that understand what I'm saying there. Great. If not, that's a discussion for another day. But I have the ability of automating the whole pipeline and deployment of models and all that. I can automate it all with SageMaker. Great. So as far as creating models, there's no prerequisites other than you need some data. Now, there are data exchanges, actually something I didn't get to, but I want you just to be aware of it here real quick. There is actually what we call a data marketplace in AWS. It's called the Data Exchange. If you just do a Google search for this, you can find it. Let me actually just give you a quick link to it in the chat so you've got it. All right, put this in the chat. Data Exchange. So you can come in here and actually check out data sets and actually browse thousands of data sets. So you want data on COVID medical data, it's available to you, and you could do training on that. You want data, it's right here, COVID right here, right? You want geographical data, geological data. You want data on, I don't know, college graduates, like percentages of things, school by school. I don't know. I'm just, you want various state data, country data, all sorts of things that might be made public. There's a whole data set here, a whole data engine you can use. So if you're going to train your own models, the only prerequisites is to be able to have something to train off of. And so training implies you have some sort of information to give it, right? Just like the learning process as a human being, right? So in any event, yeah, the link for that. I'm sorry, maybe that was related to the GenAI courses and stuff too. So I do want to wrap it up. I want to hand it back actually to Anne, basically my producer. But yeah, we've got GenAI classes we can teach. I teach many of those, and they're multi-day classes. We can go into much more depth and get some better understanding. In this short window of time, we just don't have a lot of time to go into depth. So I hope you all got at least something from this. I hope you enjoyed it. And if you want to come back and check out some of our classes, we'd be glad to have you. Otherwise, Anne, do you want to say anything before we close up?
Brian. Yes. Oh my gosh. Thank you so much. That was amazing. I learned so much here. And I'm kind of glad I was muted because I laughed out loud at Blockbuster and smiled big at the Matrix. So thanks for throwing in. And I'm seeing people are asking about the recording. Yes, we will be sending the recording. And if I could just share my screen for a moment.
Absolutely. I'm going to stop mine.
Okay.
Go for it.
Cool. All right. Nope, don't want my video on. I just wanted to just to reiterate what I said at the beginning, for a deep dive of generative AI engineering, this is a 5-day course that goes really in depth, and it can also be customized if you have a team that needs some tailoring. But if you just have 1 or 2 people to train, we have an open enrollment class, and it's actually running April 8th through 12th. So I will put this URL again in the chat, and it'll also be in your email, your post-webinar email. But also I wanted to say the only thing better than 2 hours of generative AI on AWS is 2 days of this topic. And Ryan did a great job of giving a snapshot of this course, but of course in a full 2-day course, it'll be hands-on, more discussion, much smaller groups. We had a great turnout for this today, which was amazing. But in a smaller class, you probably have time to do some more chatting and actually get your hands on and do this in exercises. And the course is running April 18th through the 19th if you're just 1 or 2 people and you want to take the open enrollment. So I will put both of those, I will just make sure that those are in the chat for you, and you'll also be, you'll get this as well when you get the recording, which should be available, probably send that out tomorrow. So, great. All right, anything else? Anything else in the chat? Anything else we need to address? Or we're about at the 2-hour mark now. So I thank everybody for hanging in there with us.
Yeah, there was one comment just in the chat. Yeah, sometimes people go to do like create an image or you create some content, and it'll be totally messed up, totally wrong. Definitely try it with some new prompts or play around with that, because a lot of times it does have to do with how precise you are in your prompt. So if you go play around with ChatGPT or any of these image production tools or whatever it is, sometimes be as precise as you can and give it some really quality inputs. And the better the inputs, the better. And this is actually where there is a skill in how good you communicate with AI. There's a skill involved in just that. And that's why more and more businesses are actually starting to ask for like ChatGPT experience. You might be you might be kind of a non-technical job, but still asked to be able to use AI and be able to interact with it. And there is a skill involved in that. That takes time to learn how to use that. So just a little tip on that. All right. Otherwise, yeah, I think we're done. Everybody, it's been a fantastic time with you. I'm really pleased to have the opportunity to share some knowledge, and I'm glad you joined us, and maybe we'll see you again sometime.